I wanted to try and squeeze out as much performance as I could out of the scene, and in the end I got from anywhere between 290 batches to maximum 610 batches in the scene. With the frames per second, there is a big difference in engine and in build. In engine, the FPS can vary from 130 FPS to 170 FPS. Meanwhile, in a build, I get around 190 FPS to 229 FPS, depending on where I look. Also, this was both tested in 1080p. Also, still talking about resolution scaling, if I natively run it in 4K, I get around 60 FPS. But I'll be showing off what I did to get these numbers. First off, the biggest hurdle for this scene was the terrain. I messed around with it a lot in the settings from the terrain builder, tweaking the pixel error, basically LODs for the terrain, editing the detail distance to be acceptable, with also some shader magic to mask it, as I have mentioned in the shader parts, and the biggest one here, enabling draw instance so that the GPU instancing actually works on the terrain itself. Terrain that is also in the distance is at a lower resolution in general as well. Rocks, trees, the clusters of crystals and the bushes all have LODs. The furthest LODs also do not have any shadows that are being casted, which you wouldn't be able to see anyways. And thanks to the fog, I can get away with making objects disappear in the distance much sooner as well. Objects that are also not moving, such as rocks, are also statically batched to save a little on batches too. With lighting, I try both default lighting and light probes in my scene, but specifically I have better performance with just the default setup instead of the probes. I don't know if this is a weird one-time deal that it's like this, but I just decided to not use them as it adds 0.5 milliseconds to the CPU with no difference in lighting whatsoever. Shadow cascades have also been tweaked, as I only use 3 cascades with a small distance. With how much overhead I still have, I could 100% actually boost this up again if it's needed. Culling is already enabled by default in Unity nowadays, but there is still something called occlusion culling, which just adds more culling from what I could tell, saving resources as well. Something very small as well is that all the transparent objects in the scene or images use alpha clipping. In a scene like this, it doesn't do that much, but it still saves a little than with just normal transparency, with the smoke as an exception. Some smaller stuff that I did that also helped with performance is just messing around with a lot of the settings inside of the sky and fog volume. For example, lowering the quality of the fog to the edge where it still looks nice but doesn't blow up my computer. Also changing the cascade shadows, as I mentioned before, to a lower distance and also having only 3 cascades. Also tweaking some of the overrides myself as well. All of the VFXs are also tweaked a little bit with how far you can see them from and at what angle they actually render in, and also the amount of particles that are being spawned. One last thing I want to show is the profiler to show kind of what the scene is doing while it's running. So yeah, here it is. I am definitely recording this part with a script and not after the fact that I've recorded every single bit before this. I totally forgot to show the profile. That didn't happen. I promise. So yeah, that's what I did to make my scene more performant. Let's talk about shaders now. First, the bush shader. The bush shader has controls on the color based on the object's Y position or using the normal vectors. I found that normals look better on plane-based bushes and with fully modeled bushes that the position works better, so I just added both to choose between them, adding a gradient color to the bush. The gradient also has an adjustable height if you want one specific color to be more visible on the mesh. You can also add a rim light to the bushes if you want to add a bit of extra color. Then the bushes can also move around and have an adjustable mask on how far up the wind should affect the mesh. The tree shader I made has something similar, that the endpoints of the branches can stop moving according to the mask, making the tips move around while leaving the end bits attached to the tree. Just like the bush shader, it also has wind affecting the movement, which is done slightly different with me wanting the trees to have a slightly different feel since the trees would capture more wind than the bushes on the ground. So it just felt right to change it up a bit. The shader also has the wind come in and leave, basically having gusts of wind to make it feel more lively and realistic on how wind is not constantly affecting the leaves in the same speed and power. That is also random for the tree so that no tree moves the same way with the same wind. The grass shader. The grass shader, just like the other two, has wind affecting the meshes, with some wind wave lines being added on top of it to give it a nicer and more stylized feel to the grass. Here I also scale the grass to hide the fact that grass is being called in or out when moving around, scaling it down to basically 0 before Unity culls the mesh completely, making culling less harsh and blocky. Also, depending on how far the grass is, the color can be changed to something different and have a nicer gradient between the two colors. Some extra shaders that I also made are for the crystals and the water. The crystals are simple, just pulsating the emission depending on time and a Fresnel effect plus a sine wave, creating a pulse of light in the crystals. That also has an adjustable height mask. The water shader is a bit more complex, with it having control on color based on how deep the water is, with the lighter color in this case showing off a fake reflection in the water using some projections and also making it move in waves. Foam also spawns on top of the water as little splotches and moves depending on the speed. The size can also be changed for any of these effects, for the foam or for the colors. And that's all I have to say about my shaders.